Hello everybody, we're going to talk more about circles and their arcs today, and specifically going to do a distinguishability between the measure of an arc and the length of the arc. So how long is the arc? Okay, the do now is all about stuff we've already covered. It's kind of review questions just to get your brains thinking about circles. Okay, so I'm going to skip that. Want to know how long this arc is. Now, if I asked you for the measure of the arc and you saw this was x degrees, you might say to me, this is x degrees. As we learned, the central angle is open in degrees, the same amount that the arc is in degrees. Okay? But the measure of the arc in degrees and the length of the arc in any unit of measure that's length, centimeters, feet, yards, miles, etc. Any linear measurement, they are not interchangeable. So an arc could be 90 degrees and be 3 centimeters or 3 miles or 300 miles, depending upon what? What does it depend upon? I know you can't answer that, but I'm giving you a second to think how big your circle is, right? Arc measure equals the angle measure. It's measured in degrees or radians. Let's not forget about radians. And an arc's length is a distance that relates to the circumference of the circle. So you're talking about it's part of the circumference, right? So in length, this is some fractional part of the circumference. Let's think about concentric circles. Concentric means they have the same center. If we add in radii, let's look at that 90-degree angle I had talked about in my sample. If I add in radii here and look at the central angles, okay, this arc is 90 degrees. This arc is 90 degrees. The measure of the arc in degrees is 90, or in radians is pi over 2. Don't panic if you don't get the radians. That's okay. Don't worry about it. All right. Are they the same length? Here's an example. If this angle is 106, arc CD is 106 degrees, and arc AB is 106 degrees. Is the distance from A to B along the arc, not a straight line distance, running along the circle, the same distance between C and D? Well, if anyone runs track, they know that the inside distance is shorter than the outside distance. The inside distance here from C to D is shorter than the outside distance. Okay? So even though they're the same in degrees, or radians, not equal in length. Okay, so the way we're going to find out how their distance, because it's not linear, we can't measure it with a segment because it's curved. Okay, we're going to use a ratio. Now, if you look this up, you're going to find different ways to figure it out. Like if you look on MathBits, they're going to use a formula, not a ratio. And that's perfectly fine. If you take a second to go on MathBits and look up length of an arc, you'll see a formula. If you look at that formula and you look at my way to do it, they're the same thing. They've just solved the proportion for one thing. All right. The ratio, comparison of two numbers by division, or fraction, okay, of the length of the arc to the circumference is equal to the ratio of the degree measure of the arc to 360. Okay, let's think about that for a second. The size of the length of the arc compares to the whole circle the same ratio, the same fractional way that this angle compares to all the way around, or 360. Right? The larger this angle is open, the more of the circle circumference that would be included in our arc. Case in point, if this is if you have a diameter, it's open 180 degrees and the arc is 180 degrees, right? Half, and it would be half of the circumference. Excuse me. So the way I figure it out is using a proportion, okay? And that proportion is this. Now, you might say to me, oh, do I have to memorize this? Honestly, if you understand the ratio, you won't have to memorize it because it will be natural to you. However long this arc is, the length of the arc, okay, is a part of, that's why it's in the numerator, 2 pi r. 2 pi r is the circumference of a circle, the distance all the way around. So part of the circle is to whole, as however big the angle is that made that arc is to the whole circle 360. So you're really doing a relationship of part over whole. And this is why I don't do a formula. Now the formula is just going to take, if you were to look it up, it's just going to take this and multiply it on both sides. So it's going to come over here and multiply. And the formula is going to look like length of the arc equals angle over 360 times 2 pi r. Now this is hard to, that's something you would have to memorize. But part over whole is much easier to memorize. And I think you'd be able to figure this out. Let me show you how I use it. Find the length of arc AC, round to nearest hundredth. So I'm going to get my calculator ready, just because I don't want to change screens and slow this down. My Wi-Fi has been very sketchy. Okay, so what I want to make note of for myself is, okay, the arc measures 75. So I know some of you will look at this and say, oh, I know 75 is the arc because central angle is equal to inscribed arc. I want to know the length of the arc. Okay, so this is a very fine line. We have to be careful. We're not asking for the 75. If you look through this quickly and say, oh, equal, good, I'm good, you're going to miss the whole idea. We want to know how far is it from here to here. How much distance is it? If someone was standing here and someone was standing here, how far apart would they be? In whatever you want to think of this as, let's use a local example. If someone is at the store standing at point A, someone is at B, someone is at C. Okay? If this is 6 feet, are A and C far enough apart? If the radius is 6 feet. Okay, this is different. I'm changing. It said 4 inches. Do you see that? I'm changing that. You could leave it at 4 inches and do it your own, your own way in the when you do the work. But I'm just explaining it with kind of a current example. Are person A and C more than 6 feet away from each other? Okay, so how do we figure out how far apart they are? Well, we're going to do how the length of the arc, that's what we're looking for, over the whole thing that goes with the length of the arc. So all the way around from A to A, okay? In distance, So I need to do the circumference. Circumference is 2 times the radius times pi. Okay, so in my new example, it's going to be 12 pi, right? Radius of 6 times 2 is 12. Equals, now I go to my angle part. How big is the arc? Well, the only thing we know about it is it matches with a 75-degree angle, okay? And that would be the part. And then the whole circle is always 360. Now we use cross multiplication to solve. 360 times the length of the arc equals 75 times 12 pi. Divide by 360, divide by 360. Make sure, if you're using a calculator, make sure that you have your whole multiplication being done, then your division. Don't put in 75 divided by 360. No, you can do it in this. You can't do it if it's in the denominator. Forget it. 75, parentheses, 75. I'm not using the GeoGebra, so I'm using my regular calculator here. Times 12 pi. I always think when I'm asked to do a calculation with pi, am I sure I wanted a pi there, or do I want to leave it in terms of pi? This question says to round, so I will put the pi in the calculator. Divided by 360 comes out to, whoops, wrong pen, sorry, 7.8539. To the nearest hundredth is here, so that's approximately 7.85 feet. So we know, because the angle is 75, we know that A and C are more than 6 feet apart. Okay, that's how you calculate the length of an arc. And there's a couple more problems for you to do. This one's kind of working a little backwards. It's telling you what the length is, and it wants you to figure out what is the diameter of the circle. So first find radius. Because we're working in a proportion, doesn't matter which piece we're looking for. So you're going to put the 88 pi up here in the top. You're going to put 2 pi r down here on the bottom because you don't know what the radius is, so you can't calculate it. Then you're going to put the 80 over 360. Okay, I'm attaching this and a homework sheet together because there's not that many problems here for you to practice. As always, if there's any questions or problems, please email me so that we can communicate and I can help you understand this material. Have a great day.